Welcome to Juran Institute's Quality Tools and Tutorial Series, Cause-Effect Diagrams. In this quick tutorial, we will define what a cause-effect diagram is, take a look at some of the key benefits of cause-effect diagrams, review the structural components of a cause-effect diagram, and take a look at an example. First, we must ask ourselves, what is a cause-effect diagram? A cause-effect diagram is a visual representation of the factors that might contribute to an observed effect under examination. It is a common brainstorming tool, often referred to as a fishbone diagram. The tool received this name because the diagram branches off of a central spine, resembling those of a fish. Cause-effect diagrams are also referred to as Ishikawa diagrams, as the tool was originally created by Kaoru Ishikawa in the 1960s. Cause-effect diagrams should be developed by a cross-functional team of people who have a working knowledge of the process. The team should represent different areas, functions, or perspectives of the process. One of the key benefits of the cause-effect diagrams is that they help project teams to organize various theories for systematic review. Additionally, they challenge project teams to look deeper into problems and continually ask why certain causes are occurring. We begin constructing our cause-effect diagram by first determining what effect we are examining. The effect is the problem or defect that the team is trying to reduce or eliminate. Some examples of common effects in healthcare are medication errors, patient infections, registration errors, or missing orders. Simply draw a box at the far right side of your paper or screen and write the effect inside. The next step is to draw a line or spine across your diagram. This line will be used to branch off into more specific detail as we develop our cause-effect diagram. Our next step is to draw our branches or fishbones. A typical cause-effect diagram will have 5 branches connecting to the spine. Each branch will have its own category. We create the 5 branches to help the project team categorize the different potential causes they identify. They are stratified into 5 separate categories based upon the 5 P's. The 5 P's stand for people, provisions, patrons, procedure, and place. People includes any internal employees involved in the process. Provisions would include any supplies or equipment required to complete the process. Patrons are the external customers to the process. Procedure represents the workflow and standard procedures and protocols within the organization. Finally, place stands for the environment in which the process takes place. The 5 P's are a helpful tool because they remind us to consider all of the possible types of causes that may exist. It should also be noted that these are not always required or applicable to every cause-effect diagram you create. It is also acceptable to determine your own branch headers that are specific to the particular effect you are examining. These 5 P's are placed at the end of each fishbone. The project team now brainstorms the potential causes for the identified effect. This is done simply by asking the team, why is this specific issue happening? As each potential cause is identified, it is placed on the appropriate branch depending on which of the 5 P's it is most relevant to. Typically, it doesn't take long to develop a thorough list of potential causes. Don't worry if some of the branches are more full than others. This is not uncommon. Just be sure to thoroughly examine as many causes as you can identify. A technique known as 5 why analysis is used to delve deeper into the potential causes for your studied effect. Begin with one single cause that has been identified by your team. You then ask yourself the question, why is this happening? This may generate one or more new potential causes. On the diagram, each new potential cause should be written along an arrow pointing back towards the cause of its origin. For each new potential cause, repeat the process and ask the team, why is this happening? The eventual result will be a series of potential causes linked to one another, resembling the branches of a tree. Ask why until the team reaches a cause that can be controlled or changed and has significant impact on the effect. This could be as many as 5 times, thus the term 5 whys. Let's take a look at an example of how this exercise works. Imagine that your project team is addressing the issue of patient dissatisfaction relative to doctor office visits. The team begins by asking the questions, why are patients dissatisfied with doctor's office visits? One of the project team members mentions that they believe that extended total length of visit times are leading to dissatisfied patients. In this case, the procedures of patient flow appear to be the issue, so the procedure branch is used. The new cause, patient length of visit is too long, is indicated on the diagram with an arrow. The team now asks, why are length of visit times too long? One team member states that patients wait too long in registration. The waiting room is constantly full, and patients spend most of their time during their visits waiting to be registered. This is indicated on the diagram by an arrow stating, patients experience significant delays in registration. The team again asks themselves, why are patients experiencing extended delays in registration? One team member from another mentions that their most frequent issue with patient registration is that they receive patients with incorrect or incomplete information. This leads to rework by their front desk, extra phone calls back to registration, and additional delays for patients. When asked why the information was incomplete or inaccurate, a registrar participating in the exercise mentions the pressures associated with registration. More specifically, that the registrars feel rushed to get patients into the system and on their ways to the unit as quickly as possible. When asked why they felt rushed, registrars mentioned the high patient volume in the waiting room. From this exercise, the project team began to track the number of patients with incomplete or inaccurate data and realized that a large amount of registrar time was spent resolving these issues. Training was provided and incentives given for accuracy with patient information. With the reduction in rework and issue resolution, the registrars now had more time to register patients. Wait times were reduced, the number of patients in the waiting room was reduced, and other internal employee satisfaction increased. And as a result of the reduction in patient length of visit time, patient satisfaction increased. Now we will display another completed example for you to observe. The following example analyzes the causes of delays in receiving lab results. Please take a few minutes to observe. You will note that the 5 branches of the diagram do not match the 5 P's. In this example, rather than use the terms provisions, patrons, and place, they have used the categories of materials, measurement, and equipment. Please also note that on this example, for the sake of displaying the full cause-effect diagram, many of the potential causes have been abbreviated. When developing a cause-effect diagram, a project team should feel free to provide as much detail for each specific potential cause as they deem necessary to clearly communicate their point. If you would like to learn more about Juran Institute and our services, please visit us at our website, www.juran.com. You may also reach us by calling our 800 number, 1-800-338-7726, or emailing us at info@juran.com. If you found this webinar helpful, please feel free to view our other tools and tutorials by visiting and subscribing to our YouTube page. You may visit it via the following link, www.youtube.com/Juran Institute. You may be interested in reading and subscribing to our blog, The Big Q, on current quality issues and topics at www.juran.com/blog. You can also follow us on Facebook by searching for Juran Institute, or Twitter by searching The Big Q. Thank you for your time.